Welcome to Visit's basic level training session on what constitutes an effective survey. As explained in our introductory course on social science, designing surveys is more complicated than you might think. The goals of this course are pretty simple. We want to try to cram highlights from a semester-long research methods class into about a 30-minute presentation, so we'll obviously be doing just the big highlights. We'll start with a brief review of social science research, which we covered in our earlier class, and follow that with a discussion on the IRB. For those of you who don't know what it is, this will be a brief introduction to that. Next, we'll discuss statistical-based social science research, and at the end, we'll present an example case of a well-designed survey that appeared in the literature recently. This course should not only help you formulate your own surveys, but should facilitate an overall understanding of what constitutes a good survey. The goal of any social science research is to understand individual and societal behaviors. There are two basic types of studies. There's descriptive studies, and these are what we're kind of used to, interviews and questionnaires and natural observations. This kind of study is used for preliminary answers and establishes correlations only. It doesn't establish cause and effect. So be careful of that. If you want to establish cause and effect, you're going to have to perform an experimental study, which is varying some of the questions within various versions of the questionnaire and applying very complex statistics to the results to see if any of the changes affected answers in any other parts of the survey. We will not be doing that in this course. So what is a survey? A survey is nothing more than a way for us to gather information about individuals and groups through a series of questions. The thing to be careful of about that is questionnaires are basically self-reporting information. So you have to ask yourself, every time you put a question together, you have to ask yourself, are the answers true? Only the participants know for sure, and sometimes really they don't even know. There can be a lot of problems like memory lapses, guessing, emotional factors, personal image problems, things like that. But by constructing a survey carefully, you can circumvent a lot of these kind of problems. Okay, let's talk a minute about the Institutional Review Board. That's a little bit complex. All right. During the middle part of the 20th century, medical and psychological studies pushed the envelope with experiments that began to have more and more potential to cause harm to individuals, to participants. The National Research Act of 1974 resulted in something called the Belmont Report of 1978, which defined ethical principles for human subjects in both medical and psychological studies. And this all led to new regulations and pre-review of all human-based research and the so-called Institutional Review Board. There's actually a lot of institutional review boards around the country. Every university has one. And by the way, if the study is if your National Weather Service regional offices typically take care of this step, so you don't need to worry about it if you're designing a survey. Okay, so on to the main topic. The first step in survey design should always be to formalize your goal. That's very important so that you can keep those questions clear and concise and focused on what you want to do. Let's say your office recently issued a winter storm warning, and a lot of people in your area hadn't reacted the way you'd hoped. So you might decide to put together a study to find out why. So what's the goal of the study? I always advise people to write it down. Let's say your first cut, somebody says, why don't we just say our goal is to find out why people don't respond to severe winter storm warnings. But this is obviously too broad brush and much too difficult a question for a single simple survey. Narrowing it down to a more reasonable scope, we might say something like to find out why people in our warning area didn't respond to our recent winter storm warning. Later, we'll show an example case, and in that example case, we'll show how the clearly stated goal helped keep the focus, made a better survey out of it. In fact, that study began with that study actually was concerned with why a lot of people in Phoenix, Arizona, didn't respond to severe heat waves during the summer in which there were several deaths. And this goal actually led to the first question on that survey, which was, over the past several summers, were you aware of days when National Weather Service in Phoenix issued an excessive heat warning? If the answer is yes, then we want to ask them why they didn't respond. But if the answer is no, obviously they hadn't heard it, so we don't know why they didn't respond. The interest here is more, why didn't they hear it? All right, so useful results. There are a lot of factors involved in designing a scientifically based question set. Um, First, survey designers need to be almost hyper vigilant, I would say, when structuring your questions that are conducive to later statistical analysis. Secondly, there is a litany of potential biases. And third, there's a problem of formatting questions that are clear, very clear, and you need to also be mindful of the study's limitations. So let's take a look at each of these separately. The statistical plan. A statistical plan is key to later analysis. You've got to keep that in mind with every question you write. With properly designed question and answer sets, analysis becomes much simpler. Sometimes not paying enough attention to this step might invalidate important parts of your study. You want to make sure that your questions are quantifiable and are comparable, and that's tough because in the case of social sciences, we're not measuring temperature or dew point or things like that. We're basically talking about nuanced responses to social and psychological situations. That is, we assign values to nuances, and this can be kind of arbitrary. A 5-point Likert scale, such as do you believe that weather warnings are accurate enough for you to act upon, with choices like strongly believe, somewhat believe, don't know, somewhat skeptical, strongly skeptical, can be assigned numbers 1 through 5. This is fine as long as you keep in mind what's being done. And remember, the answer to this 5-point Likert scale question can only be properly statistically compared with other Likert questions that have 5-point scales. The levels of nuances have to be the same, if you will. The comparison for the physical sciences would be like the accuracy of an instrument. Picture trying to compare a set of temperature measurements from thermometers with a plus or minus 0.125 Celsius accuracy with another set of instruments with a plus or minus 2 degrees Celsius accuracy. Could be done, but you don't really want to do that. Questions need to be clear and concise. We've all seen questions on surveys that leave you wondering what the researcher really wants. That kind of question distracts your participants. Also, several studies have shown that concise questions tend to yield more honest results. Open-ended questions, an open-ended question means something like you want somebody to just write out an answer, just come up with a written paragraph or something telling their opinion on a various aspect of what you're interested in. You really don't want to do that too often because remember you want all of your questions to be part of your later analysis. And before analysis, someone's going to have to go through that survey and design a coding scheme that will somehow, some way assign numbers to those written answers. Open-ended questions can end up being very time-consuming and add another level of arbitrary ranking too. That's the fear. And finally, one thing I want to point out that a lot of researchers don't know in the physical sciences is that most psychological factors like resilience and anxiety and skepticism have had measures established for them for years in the social science literature. So there's a set of questions that are already available to be used. You can find these easily enough using a search engine. If such a measure exists, it's generally expected that the researcher will find it and use the established question set since it's been shown to actually measure what you think you're measuring. Plus, it makes life a lot simpler. Now, formatting the questions. Questions with ambiguities and biases can ruin all or part of the survey's result. Keeping your questions clear is key. A good survey avoids lengthy questions with confusing language and jargon. Remember, be concise. Also, a good survey does not leave participants wondering what you want to know. Questions like what do you do when you hear weather warnings from various sources will leave participants scratching their head. A better question would be something like when you hear a winter storm watching, how do you typically react, followed by a list of choices on a Likert scale, such as I ignore it, I look outside, I make some preparations, things like that. And definitely watch out for leading or loaded questions. Obviously, a question like, should responsible people always heed weather warnings is a leading question. How are you going to answer that? A question like, why do you ignore severe weather warnings, assumes that the responder does that. It's a loaded question. So multiple people should always review your question set or review the question set for looking for these kinds of errors and getting rid of them because it will ruin your study. You want to be careful of biases. There are many common biases. In fact, I can't name them all here, but I'm going to talk about, just go over very briefly a couple of more common ones. Sampling bias, which is how you select your participants. You could get very different answers if you poll a whole bunch of college students versus go to a senior citizen home, or maybe go to a workplace or go to a shopping mall. You're going to get different answers from different groups of people. It's not possible probably to get a completely representative sample, but you'll need to get as close as you can to the sample that you're interested in if your survey results are going to be useful to you. There's such things as volunteer bias. People who volunteer for surveys might not have the same opinions as people who don't. Self-reporting bias is a big one. People sometimes practice image management. They don't want to look bad. They may have faulty memories, emotional issues. They may not understand the question. They may have a response bias where if they see a 5-point Likert scale, they never answer the extremes. They always pick one in the middle, and so forth. Nothing you can do about that. You just have to ride with it. Cultural bias. Different cultures often think about the same problem differently, and if there's a way to phrase your question to account for that, I would advise doing that. And there's also experimenter bias, where you inadvertently phrase one or more of your questions to give you the answer you think you want to hear. And those usually turn up as loaded or leading questions, and a good reviewer will pick those out and toss them. Okay, just a couple more biases, and then we'll move on. Extraneous biases: time of day, season, current weather. If you're polling about, if you're giving people a poll about severe weather and there's a severe thunderstorm going on, you might get different answers than if you gave it on a nice warm spring day, sunny day. So keep that in mind. Try to make the test conditions as close as possible to one another for all of your participants. Avoid vague questions, like I said, like questions like, do you experience bad weather regularly? Don't limit your options. Don't say, do you consider this product excellent, very good, or fair? If you don't want to hear the full truth, why do the survey? You got to say excellent, good, fair, not very good, poor. And of course, double-barreled questions, avoid those. Things like maybe how satisfied are you with weather forecasts and severe weather warnings? Okay, enough said. Now on to the example. We're going to be looking at this study which examined risk perception and warning response to NWS heat warnings in Phoenix, Arizona during the summer of 2005. And the reason for that study was that during that summer, people didn't seem to respond very well to excessive heat warnings, or heat warnings about excessive heat, during which a total of 18 people in the greater Phoenix area died. Researchers felt that a better understanding might help reduce future fatalities. So the goal of the study was simple. You can write it out: to understand why residents of Phoenix, Arizona didn't respond as hoped to heat warnings for situations that were particularly dangerous. Okay, the kind of survey that they chose to do, this was a descriptive study. It was a questionnaire, and the way they chose to distribute it, they distributed it at 8 different shopping malls in and around the greater Phoenix area. The intent was to attract a diverse range of participants with a range of ages and ethnicities that represented the Phoenix area as best they could. And it's also easy to find participants in a shopping mall. But notice, one thing you have to keep in mind, it's only looking at mall shoppers who are willing to take the time to fill out a form. Not that that's bad. You only need to keep it in mind. You might want to, if you doubt the results in any way and think that there's a bias because of that, you might want to go administer your survey a different way, 8 more surveys a different way, to see if the results are similar. Okay. Their questionnaire consisted of 17 questions. Some of them had multiple parts. Researchers estimated that the survey could be completed in about 5 minutes. I don't think it could have, but maybe 10 minutes. In the end, they got a total of 201 participants. And now I'm going to try to move over to the PDF version, which shows some of the questions that they used. I'm going to just drag this right onto the screen here and see if this works. Yes, it does. Okay, there's those first 2 questions I was talking about earlier. Over the past several summers, were you aware? And if they were aware, and if they were not aware, they were asked to jump over the next 6 questions. Okay. Let's see, I think it's questions 13 through 17 I'm interested in showing first. I always show my demographics first, but I always tell people to collect demographics because you're going to have, as I mentioned, you're going to have different answers from different ethnicities. There's going to be differences between men and women, and sometimes these are going to be interesting to you depending on what you're trying to learn. In this case, questions 13 through 17 ask questions like, where do you get your news? Are you a male or female? What is your racial or ethnic background? What is your age? A lot of times people of different ages respond differently to warnings and that, and it might be good to know that. And later maybe do a survey on how to approach different age groups if you knew it was happening. So let's look up at question 3 here. Here we go. Yeah, this is, okay, so given that you did hear the warning, and it turns out that 195 out of the 201 participants did hear the warnings throughout the whole summer. All of these questions, how seriously did you take the excessive heat warning? Were you worried when you heard about the excessive heat warning? Somewhat worried. They have, this is a 4-point Likert scale. There's 4 choices. So this is fine. Those 2 questions can be compared to one another. Also question 5 and 6 can be compared to one another. Overall, how did your daily activities change? How would your behavior change on days with an excessive heat warning? Those can all be compared with one another. But for some reason, and I haven't spoken with the administrators of this survey, for questions 7 and 8, they chose different Likert levels. For question 7, they chose 6 levels, and for question 8, they chose only 3 levels. So those they can be compared, but they can't be precisely statistically compared with the questions with 4 Likert levels, because for some reason, question 7, they wanted much more accuracy on the nuanced on the nuances that they were trying to get at. So it would have been better if they would have left them at 4. But again, that doesn't happen very much in this survey. Other questions can't be directly compared. There are other questions that can't be directly compared, but in general, this was a good survey in that mostly they stuck to 4 levels. Here's question number 9 down here, that they stuck to 4 levels, 12. And I would suggest always sticking to the same number of Likert levels. All right, so enough of that. You can look at this. We'll post the PDF on our site so that you can look at the study and judge for yourself what makes this into what I think is a fairly decent study. But let's go back to the main presentation now and look at some of the results. First, it turns out that nearly everybody was aware of the warnings. Like I said, 195 out of 201 people were aware of it. 63% of the participants in the study were female. But notice that more females than males, as a percentage, reported an awareness of the existing warning. So the women seem to be a little bit more aware. There were more women, but as a percentage, there were even more that were aware. And there seems to be a pretty good awareness across racial lines. All people, white, Hispanic, black, or other, all seem to have pretty good awareness in terms of 88%, 81%, 79, and 80. So that there was no differences there. And another thing to notice that I found amazing is that even the youngest age group, 18 to 29, even though it accounted for the lowest percentage of those who were aware of the official warnings, there were still 2/3 of them that were. So let's find out about what these people answered then. Okay, of the 169 participants who reported being aware of the heat studies and who actually completed the action questions that followed along there, about half reported they did nothing about it. This graph that shows out of those who ignored the warning, the most common reason for doing so was that they felt they were used to heat, so they didn't feel like they needed to take extra precautions. Their answer was often things like, we live in Phoenix, what do you expect? So to them there was no perceived risk. This answer, by the way, actually resonates with me. I've surveyed Front Range, Colorado residents and found the same sort of response for winter storm warnings. we live in Colorado. It snows. What do you expect? And it's really hard to make a distinguishment between what's going to be a really, really bad event and just a normal I live in Colorado event. In the paper, the authors discuss a little bit of their results, and they say that the study showed that a large percentage of residents who ignored heat warnings did so for the reason I said. It's always hot in Phoenix. The authors pointed out that if the warning had been issued for a particularly dangerous heat event, the unusual nature needs to be emphasized. Their advice was to make it special, but only make it special if and only if it is special. Somehow get it through to the public that this one is different, and that seems to make a difference. Also, another thing that makes a difference, which we already know about, there's plenty of studies in this along these lines. If you provide clear instructions on what to do about it, you oftentimes get better results from your warnings. And finally, the author suggested that since research has shown that people are more likely to act if they have clear instructions, the author suggested that city and health officials need to become more involved in getting the public to respond, perhaps by distributing water or making homeless shelters air-conditioned, things like that. But of course, those are very expensive propositions. We don't really know that if distributing water everywhere would make people more aware. So that would probably take another survey, and it might even involve a manipulative study, an experimental study, where you surveyed one large group of people and said, we're passing out water. You find the city is passing out water at intersections or at malls or things like that. And another version of the study doesn't have that, and so they can then compare the answers to the follow-up questions to see whether people would indeed respond in the situation where the city was doing something that expensive. Anyway, overall, important things to remember. Every study has to have a clear purpose and a well-stated goal. Make sure that you write down your goal and keep that at hand while you're writing your questions. The ideal survey also will provide a representative sample. It needs to be distributed so as to reach the people of all ages, economic ranges, ethnicities, and whatever that truly represent the population that you're trying to understand and get to. If you're looking at someone else's survey results, if you're just reading somebody else's survey in the literature, look at their paper and try to judge whether their survey accomplished that lofty and difficult goal of reaching the audience that they really are interested in. Surveys have to be crafted in a scientifically sound manner. Good surveys have question sets that can be statistically analyzed if you want to. Remember that numerical values in social science research represent levels of nuance. So kind of an accuracy, it's kind of an accuracy measurement in terms of measuring the accurate psychological response to a given question. And these nuances are arbitrarily assigned. So the advice is to keep your Likert levels the same whenever possible, so that you can compare all questions. You might not want to think about when you're designing your survey. You might not think about comparing, say, question 3 or whatever with question 15, but later when you're looking at it, you go, "Oh, gee, I wish I'd have made them have the same number of Likert levels, because I can see where it would be helpful to know that." And always collect demographics. Always collect demographics, because you're learning more and more and more about your target group. That's also part of building a representative sample. If you have a certain ethnicity distribution in your target group, your target audience that you're trying to reach with warnings, for example, you want to be careful that your survey has good representation for all of the groups you're trying to represent. Questions need to be clear and concise. Research has shown that answers that are questions that are concise consistently get more honest answers. People like clear and concise questions, and they'll give you an honest answer a significantly large percentage of the time than if you don't. The example case is a pretty good model to look at if you want to conduct a survey, and should help you recognize a good survey when you see one. So that's the end of the Introduction to Surveys course, and thanks for checking this out. Please feel free to contact us here at CIRA if you have any specific questions about today's material.